So I get a lot of questions about this question. So I just want to give you guys a little bit of a hint about it, because it is just deceptive in its simplicity, because it looks like, oh, I can't answer this because it doesn't give me enough information. And it's just because of how the balls went off after the collision means that we can do it in this special way. So what's happening? We have this guy going right to the east beforehand, the cue ball. It hits an object ball, and then they both go off at these angles, okay? And usually we need, momentum before equals momentum afterwards, but we don't have anything for the momentum afterwards. So it's kind of difficult to look at how we're going to do this. Okay, so what I wanted to do is bring you back to physics 20 and when we have two vectors and how we add them together. So our two vectors kind of separated look like this and this. That's not usually how we add vectors together. So how do we add vectors together? We would draw one like this, and then of course from the arrowhead of that vector, we would draw the next one like this, right? And then, of course, here, our resultant vector would be kind of like this, except the thing is, since we know momentum before equals momentum after, this bottom vector right here is actually the momentum before in the x direction, or just the momentum before of the cue ball. It's fully the momentum beforehand, because, of course, we know these two vectors need to add up to get this one, okay? So that's what's kind of special about that. What's special about this? Now, all of you guys have taken, of course, math 20 and 30 and know how to use sine law and cosine law. But what's even better here is the fact that you don't even need to. Look at these angles, 60 and 30. So this guy makes a 60-degree angle, right? Because this is the momentum of the cue ball afterwards. This is the momentum of the object ball afterwards. The object ball makes a 30-degree angle with the horizontal. So that's also, this one would be 30. Oh my goodness, when we have a 60, 30 degrees, what angle must this one at the top be? It absolutely must be a 90-degree angle. Because of course, 30, 60, 90, that's going to add up to 180. So as soon as we have that, we have two angles, we have our hypotenuse, so I should be able to find the values of this and this just by using the value of my hypotenuse, which is the momentum here beforehand, which we do have the mass here and we of the cue ball, and we have the velocity of the cue ball beforehand. So we should be able to get that momentum, which is right there, and then we can find the two sides of our right angle triangle, and that's how you do that. Okay, bye.